Right. Next one is in the. So let's have look at the JL junior lecturers and polytechnic lecturers chemistry. Polytechnic lecturers chemistry, JLPL chemistry. So TSPSC is recently, Telangana Public Service Commission recently released the JLPL chemistry, JL junior lecturers and polytechnic lecturers chemistry notification. That means junior lecturers, polytechnic lecturers notification is released. Right? In that notification, we are offering, based on the notification, we are offering chemistry subject coaching. Paper 2. Paper 2 chemistry coaching will be offered in online RR Chemistry app. RR Chemistry app. Through the RR Chemistry app, we are in the form of recorded videos. In the form of recorded videos, we are offering the coaching. In the form of recorded videos. Right? Already nearly, this is the month of mid of the month of January 2023. For this, up to this date, so nearly 60% of syllabus, as per the syllabus which is mentioned by the TSPSC for the JL and polytechnic lecturers, 60% syllabus videos are already uploaded. Already recorded videos are already uploaded. Nearly 210 videos, 210 hours of videos. Not the video length is 3 minutes, 4 minutes, 5 minutes. This is the length of 200, each one video, minimum 1 hour it may be there. Some may be exceeding that 1 hour 10 minutes, 1 hour 20 minutes also there. Excellent video content it is there. HD quality videos we are in HD quality, full HD quality videos will be recorded, video classes will be recorded. That syllabus particularly, that videos particularly based on the syllabus only. Based on the syllabus only. Out of syllabus, that means syllabus for the paper 2 only. Paper 2, that is for the chemistry only, we are recorded. Right? So previously I am offering the coaching for the APPSC, Andhra Pradesh Public Service Commission, JL as well as the DL also. Nearly 8 members are selected in that post. 8 members are selected. Through offline mode, I previously I am offering the coaching in the, I am offered the coaching in the offline mode at Narayanaguda, Hyderabad. And also Gurukula, JLDL also I am offering the coaching in the previously. Nearly 6 members are selected from that notification. Right? And also another one, if it is CSR coaching, it may be I am offering CSR coaching, CSR net. Many of the members, CSR net particularly I teach physical chemistry only. Right? Here it is also in offline mode, I am offering physical chemistry only. Now it also I am offering in offline mode physical chemistry only, but in online mode, in addition to the physical chemistry, organic and inorganic also I am offering in online mode. In offline mode only physical chemistry is offering, because most of the members are demanding, there is a huge demand for the physical chemistry point of view. So based on that, I am offering offline only for physical chemistry, in addition to that online. Right? So previously I am offering the coachings. I already conducted the coachings for the JLDL of Andhra Pradesh Public Service Commission and TSPSC. That means in the Telangana Gurukula board which is conducting the exam, Telangana Gurukula JLDL also I am offering the coaching, and CSR net also. Right? CSR net, it is also there in the now also CSR net coaching which is available in online also. Right? For all subjects. For all subjects means the organic, physical and as well as inorganic. Now let's have to look at the syllabus and the number of posts also. You know that all are very well aware of that number of posts. So TSPSC multi-zone 1, 65 posts are there for the chemistry, and for the multi-zone 2, 48 posts are there for chemistry, total of 113 posts which is there. And for particularly in the Urdu medium, and 6 posts are the multi-zone 1 and 13 are the multi-zone 2, total having 19 posts are there. So total which is having 132 posts which is chemistry, 113 is for common for all, and particularly in the Urdu medium is 19 posts. And the important thing is in the subject. In subject, exam will be conducted paper 2 in all subjects. Some of the subjects will be exemption is there, but the chemistry in paper 2. Paper 2 exam will be conducted in English medium only. Is mentioned in the syllabus, English medium only. Paper 2 exam will be conducted. And paper 2 is there. Paper 1 is, you know that 150 marks, each one carrying 1 mark. Paper 1, scheme of the examination, 150 questions are there. Each one carrying 1 mark. How many total is having? 150. But paper 1 is general studies. I am not going to take the general studies. I am not offering, right? Which is irrelevant in this particular point of view, because I am offering only for paper 2 only. Paper 2 is the deciding factor. So how much you are expertise in paper 1, but paper 2 is deciding factor, because paper 2 carrying, here it is also 150 questions are there, though it is 150 questions, but paper 2, each question carrying 2 marks. Total is 300. So 300 marks is for the paper 2. So total having 450 marks which is there. This is the generalized, that if you open the notification, all those points you can, it is appears generalized paper 1, paper 2, mode of the examination, conducting mode of the examination, and how many posts are there. And you know that all those information. Now we are going to the syllabus. Syllabus is what? For the paper 2. Paper 2 syllabus is somewhat compared to the earlier examination. The JL junior lecturers and political lecturers and degree lecturers examinations earlier the TSPSC is conducted in the 10 years back. That means in the combined Andhra Pradesh, 10 years back the examinations are conducted previously. Notifications are released 10 years back, approximately. Right? So that at that point of view the syllabus is different, and this point of view syllabus is different. The same syllabus will be there, that means almost same syllabus will be there for the APPSC junior lecturers, polytechnic lecturers, degree lecturers, and Gurukula syllabus also. You can compare this, the TSPSC chemistry, JLPL chemistry. At this present notification, most of the syllabus are matching with the earlier notifications of the APPSC DL, PL, JL as well as Gurukula JL, PL. So that I am offering earlier coachings for these two. Based on that, I have already 210 hours of video classes is available for me. Right? Already is available. The rest of the syllabus, whatever that, if it is 40%, if it is there, that can I upload within 1 month. Within 1 month time. That means for the end of the end of the February. So total syllabus will be uploaded. So whatever that, if it is, they can purchase the videos, recorded video. For that, I already uploaded many of the videos in the RR Chemistry app. RR Chemistry app. You can download the app from the Play Store. You can visit the Play Store. The Android users, if it is Apple users, download My Institute app, search for the institution code XZTXU. If it is Apple users, Apple users, iPhone users, right? So when it is download the My Institute app and enter the search code XZDXO, it is automatically downloaded. Or you go, if anyone wants to download the app, if it is any trouble you have to face the Apple users, you can contact me. You can contact with me. My number is 82475-27959. Right? You can contact me. I can send the link also. You can download the app. So for Android users, you can go to the Play Store and search for the Rrchemistry. Then you can download the app. So in that app, nearly 210 videos, I mentioned that. Most of the videos is already available. If it is particularly physical chemistry syllabus, 90% of physical chemistry syllabus I already uploaded in the recorded videos. I already uploaded in the form of recorded videos in Rrchemistry app. 90% already covered that syllabus, physical chemistry point of. And in the inorganic chemistry also at this mid of the month of January. So up to this. So physical in inorganic also the entire coordination chemistry related units I already upload that. Coordination and reaction mechanism, metal complexes, stability of the metal complexes, and also metal carbonyls like that already uploaded. Some of the units it may be pending, and even though organic also stereochemistry, pericyclic reactions, and reactive intermediates, and some spectra also I already uploaded. Remaining will be take 1 month of time, right? All it may be uploaded. Right. So the syllabus variation it is there. Syllabus the paper 2 in, while you can compare with the previous examinations, the syllabus is entirely different because 10 years back the examinations notifications released by the TS in the combined Andhra Pradesh JLNL notification is released 10 years back. But so that at the time of syllabus is different compared to this syllabus. When the syllabus is matching with, I already mentioned that it is matching with the AB basic DL, PL syllabus and JL syllabus as well as Gurukula JL, DL syllabus. You can compare with the syllabus of this present notification. Right? The teachers, whoever they can teach this, suppose in the lower level, it is in the school level, or if it is some of them, it may be in intermediate level also. They are offering the coachings, but it is impossible to cover all those, as per my knowledge, it is impossible to cover all those topics. Without having any, they have knowledge in some sort of area, but it is not all these areas, right? So before that you are deciding which institute is best for the JL, PL chemistry, you thoroughly inquire that and you thoroughly listen the videos. And you also question that whether this total syllabus will be covered or not. That is important. Total syllabus will be covered or not. Having the good knowledge in the total syllabus or not. Right? That is only I can tell you. Right? So now coming to the syllabus of the paper 2 is what? Paper 2 syllabus. Let's look at the paper 2 syllabus. So the syllabus, paper 2, chemistry syllabus, you know that it is mentioned in the 3 parts, organic, inorganic and physical. Physical chemistry is 1 part and inorganic chemistry is mentioned in the syllabus is another part. Another one, you know that in the organic chemistry. Right. For each one, that means organic, inorganic and syllabus, physical. So how to start the preparation based on the syllabus, because what is mentioned in the syllabus, that is important. How to read the syllabus, how to understand the syllabus, and based on that, how to start the preparation. That is important for the preparation method. Right. So for each one, I make a separate videos for the physical, inorganic, and organic syllabus because it is if it all combined, that length of the video it is very high, very long time it is there because the syllabus range is also like that. So I make the separate videos for physical chemistry, inorganic, and organic separately. So for physical chemistry point of view, I make the which one is mentioned in the syllabus? Physical chemistry. Paper 2, physical chemistry is what is that? What is mentioned in the syllabus? Paper 2, physical chemistry. Paper 2, physical chemistry. Physical chemistry. Starts with the physical chemistry, right? Because it is important in the to clear the JL, PL, all even in the other competitive examinations also, the physical chemistry is played a key role, right? Physical chemistry and RR chemistry app. We are offering the coaching in online mode, RR chemistry, and offline also the physical chemistry is available. RR chemistry app. Offline is available at Hyderabad. Only for physical chemistry, that is particularly weekend classes. Weekend classes, full day classes, weekend, Saturday, Sundays, and some other public holidays. I am offering offline coaching also, and recorded videos for online oral chemistry app you can download, right? Now, what it is mentioned in the syllabus, right? Syllabus here it is mentioned in the physical chemistry, the units which is mentioned in the syllabus, solutions and colligative properties, mention one unit, solutions and colligative properties. And another unit is mentioned in the syllabus, acids and bases. Acids and bases is another one unit is mentioned in the syllabus. And the third unit mentioned in the syllabus, which is having electrochemistry. Electrochemistry is mentioned. Another unit which is mentioned in the syllabus, quantum mechanics. Quantum chemistry or quantum mechanics is mentioned. Another one unit which is mentioned in the syllabus is thermodynamics. Thermodynamics is mentioned. And another one unit which is mentioned in the syllabus, which is it is chemical kinetics. Chemical kinetics. Another one unit which is mentioned in the syllabus is the solid state chemistry. Another one which is mentioned in the syllabus is photochemistry. Physical photochemistry. It is also mentioned in the organic also, that is organic point of view. Right? Chemical reactions point of view. This is physical properties based on that. Right? So here it is, there are eight units which is mentioned mainly in the syllabus, which is solutions and colligative properties, acids, bases, electrochemistry, quantum mechanics, thermodynamics, chemical kinetics, solid state and photochemistry. Right? The solutions and colligative properties, which is in our undergraduate level and intermediate level, particularly in the intermediate level of IIT, JEE mains, exam mains and advanced level, the questions will be there. Right? And in acid basis also like that. But the electrochemistry syllabus is completely different. Starts with Nernst equation and cells and deep vehicle theories like that is mentioned. I can discuss every unit. This is completely, which is PG level unit. PG level unit. Right? And quantum mechanics is completely for your PG level unit. And thermodynamics syllabus is also mentioned completely postgraduate level, that is MSc level syllabus. And chemical kinetics also particularly mentioned that level. And solid state is mixed of that, mixing. Solid state unit is mixed for the UG level as well as the PG level. And intermediate also it is there. UG means here it is, UG is undergraduate level, it is at the degree level, or it is intermediate also. IIT JEE means if it is those who have prepared, right? That means those who have to teach, that you know that very well of the solid state chemistry. So that is in the intermediate level, undergraduate level, PG level. Some will be mixing it may be there. This is completely PG level. This is UG levels and below that UG levels. That means here it is intermediate level syllabus will be there. Solutions, colligative properties, right, and acid bases. So now each one what is mentioned in the particular unit as per the syllabus, each one what it is there, how to start that. So I can start with this solutions and colligative properties. Solutions and colligative properties, what is mentioned in the syllabus. Solutions as well as colligative properties. The first unit is, what is that first unit? Solutions as well as colligative properties. Solutions and colligative properties. First unit, which is mentioned in the syllabus. In this particular unit, first mentioned is types of solutions. Types of solutions. Types of solutions. Right? So if it is solid is dissolves in the liquid, what will happen? Gas is dissolves in the liquid, what will happen? Liquid is dissolves in the liquid, what will happen? Liquid solutions. And again, if it is liquid is dissolves in the solid is what? Gas is dissolves in the solid is what? And liquid is dissolves in the solid is dissolves in solid what? Solid solutions. Right? And liquid is dissolves in the gas, what will happen? Gas is dissolves in the gas, what will happen? And solid is dissolves in the gas, what will happen? Gaseous solutions. Liquid solutions, gaseous solutions, and solid solutions. That is having types of solutions which is there. Based on these types of solutions, further, before that, after these types of solutions which is mentioned in the syllabus, concentration, expression of concentration terms. Expression of concentration terms. So how to express the concentration terms? So which is mentioned in the syllabus, weight percentage, and that means weight or mass percentage, and volume percentage, and mass by volume percentage. Mass by volume percentage is mentioned, and parts per million, and mole fraction. What it is the mole fraction, and molality is mentioned, and molarity is also mentioned. Molality and molarity, right? So though it is normality is not mentioned, but it is useful in the problematic point of view. It is useful, and in the electrochemistry point of view also useful, and in particularly acid basis point of view for the calculation of pH and its related cases, everywhere this normality is used. So it is, though it is not mentioned in syllabus, but you can also read this normality also. This is the expression of the concentration terms. Weight or mass percentage. How to express the concentration in mass percentages or weight percentage and volume percentage? How to express that? Mass percentage, volume percentage, or mass by volume percentage, right? And parts per million and mole fraction. So before weight percentage and volume percentage, volume fraction is what? Weight fraction is what? Or mass fraction is what? From based on that starts with the syllabus. Right? And molarity is what? And its relations. And normality is what? What the relation? How to calculate the equivalent weight also. That is also important in the case of the normality also. And molarity in case of the molecular weight, how to that? It may be fundamental things also there. Molality is what? And what is the relation between molality and normality, and all those interlinked. And also it is how to relate it with the mole fraction, and how it is related with the volume, weight percentage or mass percentage, volume percentage, and mass by volume percentage. All it may be having the formulas which are there, useful in the problematic point of view. Right? So this is the expression of the concentration terms. One is mentioned. You read the syllabus. And another one. After then you go for this. First you start with this. After then you complete it. After then you go for the In the types of solutions, based on the solid solutions, liquid solutions and gaseous solutions are there, but focused on the liquid solutions only further. Based on the liquid solutions. That means based on the liquid solutions, particularly based on the solubility, even further it may be classified that solutions. Was taken the liquid solutions based on the solubility of the liquid solutions. When liquid is dissolved in the liquid, solubility of liquid is mentioned, one liquid in another liquid, and solubility of gas in liquid is mentioned, another one, gas in liquid, and another one, solubility of solid in liquid is mentioned, solubility of solid in liquid. Here three concepts will be there depending upon the solubility. Solutions depends on the solubility, types of solutions is mentioned in another one. And in this purpose, liquid in liquid purpose, you can discuss so based on that, it is an ideal solutions, it is there, depending upon the miscibility. It is completely miscible or not, based on that, if it is miscible solutions, it is a liquid in one liquid in another liquid, miscibility is there. It is completely miscible or not, you know that. So in all ratios, based on that, ideal solutions are there, non-ideal solutions are there. If it is miscible, completely miscible ideal, non-ideal is there. So in ideal solutions case, it was mentioned the syllabus, Raoult's law. What is Raoult's law? Based on Raoult's law, what is ideal solutions and non-ideal solutions? Non-ideal solutions, again it may be having two types. Non-ideal solutions, as again it may be having two types, which is mentioned in the syllabus. Positive deviation and negative deviation. Which is, though it is not mentioned in the syllabus, non-ideal solutions is just mentioned, but so positive deviation is what? Negative deviation is what? Solution showing positive deviation, negative deviation also you can study. And what are the examples you can study? And azeotropic mixtures also, it is related with this. You can also studying the azeotropic mixtures also in this particular context. And vapor pressure, composition curves are what? And boiling point, composition curves are what? Right, all those you can study in the non-ideal solutions point of view. Up to that is enough for the non-ideal solutions and ideal solutions. Right. Next. So this is for the liquid solubility of liquid in liquid. Just mentioned in the syllabus, ideal, non-ideal, and Raoult's law is mentioned. So you can add positive, negative deviation types of non-ideal solutions. And based on that, vapor pressure composition, boiling point composition, and azeotropic mixtures. Up to that, and fractional distillation. Based on that principle, azeotropic mixtures are there. Right? Next. And go for the another one. Solubility of gas in liquid. I mentioned that another one is gas in liquid. Solubility of, depending upon solubility of gas in liquid. Here in this case, it may be introduced the Henry's law, Henry vapor pressure law, Henry's vapor pressure law. You can study the what is Henry vapor pressure, Henry's law, and which factors are affecting the solubility. The factors are affecting solubility of gas in liquid. Which factors are influencing? What is temperature effect? What is pressure effect? Right, all those is, if it is nature of the gas is what and nature of the solvent is what, you can all those it may be studied here in this purpose. And Henry's law applications also it is important, and limitations also it is important, right? And certain graphs also there, based on the graphs also earlier examinations questions also there for this Henry's law point of view, right? And also in this Henry's law purpose, and mentioned, this is mentioned in the syllabus, Henry's law and solubility of a gas in liquid, and Henry's law, Henry's vapor pressure law is just mentioned. So in addition to that, you can studying this, right? Henry's law. And Henry's law is there. After that, Henry's law is a special case of Raoult's law, or Raoult's law is a special case of Henry's law. Henry's law or Raoult's law is a special case, right? That means Raoult's law is a special case of Henry's law. Raoult's law is a special case of Henry's law. That means you can compare with these two laws, whatever the law, Henry's law, and whatever the law, Raoult's law, you can compare with those two, and what it is happening, comparison also you can take place. And another one more here in this, liquids in liquid, based on the miscibility, if it is completely miscible, ideal, non-ideal. If it is partially miscible is also there. You can also studying the partial miscible concept also. In this concept, partial miscibility concept, critical distribution coefficient, it is introduced. Distribution coefficient is there. Partially miscible liquids, critical solution temperature concept is there. Phenol water and triethylamine, nicotine water, nicotine water, like that. Partial miscible liquids also there, right? So critical solution temperature and below critical solution temperature and above critical solution temperature and between the critical solution, that based on that questions also you may be expecting critical solution temperature. Another one it is having, depending upon the liquid in liquid, another one also you can read it, you can study in immiscible. If it is immiscible also there, in immiscible what we can study, then the distribution law is what? And if it is solute is going to be association takes place and dissociation takes place, what will be happening, right? And distribution coefficient or partition coefficient is what? That one you can study it in the immiscible solutions. Depending on solubility of one liquid in liquid, miscible, immiscible, partial miscible, based on that you can study it. You can follow the syllabus, and gas in liquid you can follow the syllabus. Right? This is the, and another one it is in the solid in liquid, depending upon the solubility of solid in liquid. It is very limited, right? Very limited, within very less concept. In particular mentioned in the syllabus, right? The area of the scope is very less, right? Questions are there. So this is the, depending upon the solubility is mentioned in another one, and another what is mentioned. This is one case, right? Another one is mentioned in the syllabus. Another which is mentioned, that is the soluble solutions and colligative properties. Another one is mentioned. That is let's see. Right. You know that the first one is mentioned. Next one is colligative properties is mentioned. Colligative properties. This is also mentioned in the solutions unit. Both are combined with one unit, solutions and colligative properties. The colligative properties, depending upon the nature of the solute, non-volatile solute is dissolved in the volatile solvent. There are 4 colligative properties which is there. It's mentioned in the syllabus. Lowering of vapor pressure, relative lowering of vapor pressure. Relative lowering of vapor pressure is mentioned. And another one is osmotic pressure. And another one is depression in freezing point, or before that elevation in boiling point. Elevation in boiling point. Another colligative property is mentioned in the syllabus, depression in freezing point. Depression in freezing point is mentioned in the syllabus, these 3. In addition to this, in osmotic pressure cases, what is osmosis and what is reverse osmosis, and how to purification of the water, how the water purification takes place by the reverse osmosis. Also you can study it here. And what is Van 't Hoff's law also you can study here. And it was mentioned colligative properties, and particularly in the colligative properties is also mentioned for the determination of molar mass. Determination of molar mass or molecular weight or molecular mass. How to determine the molar mass or molecular weight. That means you studied this, where lowering of vapor pressure or osmotic pressure or elevation in boiling point and depression in freezing point, right? Relative lowering of vapor pressure and osmotic pressure. So all those you can study it. Its relations also important. Its relation with the molality is what, and mole fraction relations are what, right? And how these four are interrelated with each other. How this is related with that means number of particles and nature of particles. It is important. It is independent. These properties are not depends upon the nature of the particles. It depends upon the number of particles. That's why colligative properties, number dependent properties, right? I already mentioned that in the. So this four, and it's related with how to calculate the molecular weight or molecular mass. That is also important. Relations. And those relations, each one you can studying independently, and its relations also there. And each one is interrelated. That relations also it is important. Then, if it is the molecular weight, you have to calculate by using these colligative properties. If these colligative properties of the solutions of the ideally diluted solutions. These are properties of the ideally diluted solutions. So if the solute is, depending upon the solute nature, if it is electrolyte in nature, it produces ions, then it is going to dissociation takes place. If it is combined takes place, then association takes place. Then dissociation or association takes place, deviated from the ideal ideality. That means Raoult's law is deviating takes place. Then which one if it is happening? Here it is. When Raoult's law is, that means colligative properties, deviating, that means the properties of the ideal solutions, if it is deviations or errors, based on the deviations, abnormal molecular masses or molar masses. Abnormal molar mass or abnormal molecular weights. Another one concept is mentioned in the syllabus. That means here it is how to study this want of factor. The want of factor is also mentioned in the syllabus. Want of factor is also mentioned. If deviations are there, how to get the normal molecular weights? Want of is proposed one equation. That want of equation, based on that want of equation, want of factor is how to calculate that. For each one case, how to calculate the want of factor. And if it is abnormal molecular masses are obtained, how it is. When it is dissociation or association takes place. Dissociation takes place or association takes place. If partially dissociation takes place, what will happen? Complete dissociation takes place, what will happen? And want of factor range is what? And here it is also partially association takes place, complete association takes place, what it is happening, the want of factor range, and what it is the equations, which one equations are there, right? And how this want of factor is related with these four also, it is important, right? So this is the another one, colligative properties is mentioned in the syllabus. You read that syllabus, and also in that syllabus is also mentioned another one in the first unit, phase equilibria. Phase equilibria is also mentioned in the solutions and colligative properties. Phase equilibria is mentioned in the form of phase equilibria. What is phase equilibria? How to read that? Phase equilibria, here it is mentioned in the syllabus, phase rule and its applications. And its applications to one component and two component systems. One component and two component systems is mentioned in the syllabus. It is syllabus is mentioned in one sentence, just phase equilibria, phase rule and its application to one component, two component. But it is a wide range of topic. What is phase rule? Based on the phase rule is which one? F is equal C minus P plus 2. That means number of phases, how to calculate that. Number of components, how to calculate that. Number of degrees of freedom is how to calculate that. And what is the degrees of freedom? What is component? What is phase rule? It is wide range concept, right? The scope, it may be, area of the scope, it may be mentioned, though it is mentioned one sentence, but the syllabus range is somewhat high while you go for the 1-1-1. First you discuss the phase is what, components are what, and degrees of freedom is what, how to determine for the gaseous systems and solids if it is given, liquids is given, if it is mixtures are given. And sometimes it may be given equimolar ratios, not suppose if it is given, suppose sometimes in APDL or JL examinations, in the earlier one, these questions are mentioned. NH3 gas plus HCl gas. You never expect all those questions are simple in one form. So if it is, the equimolar ratios will be given NH3 and HCl. And number of phases are what, components are what, and degrees of freedom is what. If non-equimolar ratio, though it is gases, if non-equimolar ratio is mentioned, sometimes partial pressures also not equivalent. Pressures are given same, pressures are not equivalent. P of NH3 is not equal to P of HCl also. It is gases expressed in the form of concentration in the pressures. So what it is happening, all those. It is different. Right? How many phases are there? Phases are gases, one phase, solid is a phase. You can easily tell that. Two phases. But components are how many? And degrees of freedom is how many? If it is same is there or different is there. Suppose if it is iron solid plus H2O in vapor form, FeO solid plus H2 gas, how many number of phases, degrees of freedom and components? Or if it is KClO3, here it is KCl plus 3/2O2 if it is there, what is the dissociation of the KClO3? So different it may be there depending upon so many questions I already mentioned in the videos point of view. You can also check that. So this is the phase rule and its applications point of view, all those you can study it. To the one component, two component. One component particularly water system you can take, or sulfur system also one component, and four phases are there. In that case, what is happening here it is, which one is the phase rule? And while the phase diagram you can check that for one component, because the phase diagram also questions are there in the earlier one examinations. So like that it is mentioned in one water system. One line is mentioned here, another one line is here, another one is here, another one is here. How many phases are existing and how many components are existing, and what is, instead of the concentrated components, what is the degrees of freedom at this point A, B, C, D. These points of locating A, B, C, D for the water system, how many degrees of freedom. That means you have an idea about that this area is which one is there, this area is which one is there, this area is which one is there, and for this curve which one those two are in equilibrium, which one those two are in equilibrium, which one for the water system. Based on that, how many number of degrees of freedom, based on the phase rule, you can apply that. Or areas are which one, if it is bivariant or monovariant or univariant, which one is there. Curves are which one, and points are, curves is what, points are what, and areas are what. That also you can study in the phase diagram for the one component and two component. Ka water system is what for two component, Ag Pb system is what, right, like that. So this is for the first unit is mentioned in the syllabus. Solutions and colligative properties. How to read the solutions and colligative properties, you have an idea about that, right? I already uploaded this entire unit in the app. I already uploaded this entire unit, right? And second unit mentioned in the syllabus, that is physical chemistry paper 2, second unit mentioned, that is acids and bases. It was mentioned in syllabus, acids and bases. Acids and bases. Let's discuss the syllabus of acids and bases, what he was mentioned, how to start the preparation. So based on the acids and bases, it was mentioned acids, bases and salts. Acids, bases as well as salts, it was mentioned. Acids, bases and salts. So broadly acids, bases, salts, these three is mentioned in paper there, right? And further it is mentioned, based on the acids and bases, Arrhenius concept. What is Arrhenius? According to the Arrhenius concept, what is acid and base and its examples and its related things. And Bronsted-Lowry, according to his concept, what is acid and base. And also Lewis concepts. According to Lewis concept also, what is acid and base. That means the classification based on these three, according to their Bronsted-Lowry and Lewis and Arrhenius acids bases, he was mentioned. Arrhenius acid bases. Acids and bases. This classification is one case, it may be mentioned. All those it may be there in the classification point of view. And further, after the classification, was going to the ionization constant or ionization of. Next one is the ionization. This is the classification, right? Here it is classification. Next one it is mentioned ionization or dissociation, like that. Ionization of acids and bases. Acids and bases. Ionization of acids and bases he was mentioned. And in this ionization, ionization of water, ionization of water or ionization constant of water. He was mentioned ionization constant of water, that is Kw. Ionization constant of water, and ionic product is mentioned. And ionic product of water. And its ionic product of water. It's water relation it may be mentioned, Kw. This is one concept is mentioned. And further, based on the ionization of acids was mentioned pH scale. pH scale, that means pH is what? All those pH related things, all those we can discuss here in this point. pH of the acids, bases, and mixing of the acids, mixture of the bases, and similar acids, if it is mixing takes place, what will be happen, the pH how to calculate, that pOH how to calculate, that all those it may be explained in this calculations point of pH mentioned, pH and its related problems. Right? Here it is also so much of concept it is there, and it is this concept which is interrelated with the, I mentioned very beginning in the solutions, that it may be interrelated, it may be there. Interrelation is there. Problematic point of view, I can explain this. pH scale and ionization of weak acids and weak bases. Ionization constant of weak acids as well as weak base. So Ka as well as Kb. Right? And its relation, ionization constant or ionization of weak acids and weak bases was mentioned, ionization of weak acids, weak bases, and relation between Ka as well as Kb mentioned in the syllabus. What is the relation between Ka and Kb with respect to the ionization of weak acids and weak bases? This is also one concept it is there. And pH Ka relation is also what, pH Kb relation is also what, all those we have seen in these particular cases. And another one which is mentioned in the syllabus with respect to the ionization of the acids and bases. After then Ka and Kb was mentioned factors which are affecting on acid strength of acid, which factors are affecting on the acid strength. And in that particular concept, he was mentioned common ion effect. Particularly common ion effect of which one? Ionization of acids, bases. In the ionization of the acids, bases, what is the effect of common ion? Common ion effect is what? That is mentioned in another one in the syllabus. With respect to the ionization of, though it may be mentioned. Right? Common ion effect of ionization of acids and bases. Another one which is mentioned, what is dipolybasic acid and dipolyacidic base concept. dipoly basic acid and dipoly acidic base. This is one concept he was mentioned, right? And in further another in the acid base concept he was mentioned in the syllabus. That means the syllabus notification is mentioned. Syllabus notification: hydrolysis, salt hydrolysis, salt hydrolysis, salt hydrolysis or hydrolysis of salts. Here salt hydrolysis it mentioned and its pH relations and its pH and its relation with its pH or its pH of and its pH of solutions and its pH of solutions, right? Salt hydrolysis, right? Salt hydrolysis, it may be different types, it may be there. Salt of the weak acid, weak base, salt of the strong acid, strong base, salt of the strong acid with weak base, or salt of the strong base with weak acid. 4 types it may be there. Based on the 4 types, what you have to identify here it is degree of hydrolysis is what, and hydrolysis constant is what, and its relation with the Kw, ionization constant of the water, and its relation with the Ka, and acid dissociation constant, and base dissociation constant, and its relation with the pH is what, and how to calculate the H plus ion concentration, and how to calculate the OH ion concentration in normality terms. Based on the H plus ion concentration, how to calculate the pH, because its relation with the pH, how to calculate the pOH, and what is the relation between pH and pOH. All those we have studied in the salt hydrolysis concept. Somewhat that is scope of the area is also there, the question scope is also there, right? Here in this particular point of some lengthy of syllabus it may be there, right? Each one salt, each one type of salt, we have seen the relations, pH relations are what, and H, how to calculate that KH, how to calculate that KW, and what is Ka, Kb, how they are related with all those, we have seen that. Right? Another one last which is mentioned in the syllabus, buffer solutions. Buffer solutions. And buffer solutions are how many is there? That means acidic buffers are there and basic buffers are there. And its relation, that means its relation with the pH, that pH relations will be explained by the, which one here it is Henderson. So here it is Henderson equation also, we have seen that. Buffer solutions and Henderson equations, pH, pKa, pKb. When Ka, Kb, you know that pH and pK. What is the relations here? In this relations also it may be extended to the pH as well as pKb also. Right? Henderson equations are there based on the concentration of the salts and acids as well as the concentration of base and salts in the case of the acidic buffer and basic buffer. Based on that, which one is the selection of the buffer? So either it may be acidic buffer is what and basic buffer is what. Which combinations it may be acidic buffer, which combination it may be basic buffer, right? And another one it is how it will be working and what is its Henderson equation, and based on that related problems also there. This is the acids and bases concept was mentioned in the syllabus. Acids and bases, right? Acid bases are what according to the Arrhenius, Brownstein-Lowry and Lewis concepts. And examples and its related things all are explained at one place. And further ionization of the acids and bases, what is the ionization constant of water and ionic product of water, and pH scale and its relation with the ionization constant of the weak acids and weak bases are what, and relation between Ka and Kb is what, and factors affecting on the acidic strength, and particularly the common ion effect of what is the common ion effect in the case of the ionization of the acids and bases. If it is common ion is there, what will be happening, right? And another one dipoly acidic base and dipoly basic acid. And another one is salt hydrolysis or hydrolysis of salts and its pH of the solution, right? So many types it may be there depending upon that. Acid strengths and base strength, weak it may be, strong it may be there, different, that 4 types it may be possible. The salts which can be generated from the strong base, strong acid, strong weak base, or weak acid, strong base, or both are weak. And another one, it is having buffer solutions and its Henderson equation. That it may be the concept was mentioned in the acids bases, right? So in app, this concept is uploaded already. This concept is also uploaded already, right? Remaining concepts which is there, that it may be uploaded within 1 week, right? Because this is the mid of the January, right? 2023, right? Within 1 month, I can within 1 week, this whole concept I can upload it. Right, in the earlier one I mentioned solutions are completely uploaded. This is also completely this partially uploaded because it's time taking process. Daily 2-3 videos, 3-4 videos I am uploading. Right. This is the acid base. Next, another one unit discussion in the physical chemistry point of view. Next, another one unit which is mentioned in the physical chemistry syllabus. That is third unit which is mentioned, thermodynamics. This completely PG level it may be there. That means the undergraduate level also, basics also it may be involved. How to start the thermodynamics? How to start the preparation? Right. First, what is system? You can start with basic, right? Because while going the based on the syllabus, if it is preparation is going on, sometimes it may be doubts or arises in your mind. Because sometimes it is mentioned isolated system. You don't know that what is isolated system. Closed system is what you don't know that. Open systems are what you don't know that. Right, state functions, what you don't know, path functions, what you don't know. So the based on that's why I mentioned you start with the preparation, system, surroundings, and state functions, path functions, right, as well as isolated systems, closed systems, and open systems, extensive properties, intensity properties. These basics you have to study before starts that. And as per the syllabus, it was mentioned. First law, a brief review. Brief review of first law and second law of thermodynamics. Second law of thermodynamics. First law was mentioned and second law of thermodynamics was mentioned. Right? You know that first law and second law, various forms it may be there. Though it is brief review, the mathematical equations are obtained and failures are obtained based on that. Second law is what, which purpose, and some failures also it may be there. So that is second law and first law, you can study that. After based on the second law and third law, further it was mentioned in the syllabus, concept of entropy. Concept of entropy was mentioned. Concept of entropy. Entropy concept was mentioned. What is the concept of entropy? Based on the entropy concept, you can also study the entropy as a state function. Entropy as a state function. How can you prove that? Entropy as a state function. Right? That is mentioned. After then, syllabus is mentioned. Entropy changes. Change in entropy or entropy changes in various processes of the ideal gases. Entropy change for ideal gas and in various processes. Various processes may be mentioned means that means change in entropy. Delta S is what for ideal gases? How it depends on the pressure and how it depends on the temperature, how it depends upon the volume, like that. And entropy changes for the ideal gas and various processes. If the process is isothermal, what will be happen? If the process is isobaric, pressure is constant, what will be happen? If temperature is constant, isothermal. And if it is isochoric, what will be happen? Right? And adiabatic, what will be happen? You can study along with this. It is not mentioned, but the various process entropy change for the ideal gases, that means isothermal, isobaric, isochoric, and adiabatic, what changes will be observed. Some equations are there, based on the problems are there. In physical chemistry, problems are there, concept is there. So you never expect all are problems in the examination. It is not there. Right? The concepts also there. Concept also, based on the concept also, questions will be there. Right? Though it is problems will be there, some of the problems will be only the difficulty level is high. Some of them it may be medium range, it may be there. Most of them is easy, direct principles related, it may be there. Though it is problems, right? So entropy is a state function, and entropy changes for the ideal gases. This is one of the concept. And when mixing of the ideal gases takes place, what is the entropy change? Another one which is mentioned, entropy change, delta S for mixing of ideal gases. Here it is also equations are generated. Based on these equations, all the questions will be there, problems will be there. Entropy change for ideal gases. Entropy change for ideal gases, for mixing of ideal gases. And another one which is mentioned in the syllabus, and I mentioned that entropy is a state function. Based on the state function, entropy is a state function of temperature and volume. And similarly, another one is mentioned, entropy is a state function of temperature and pressure. How it is a state function of temperature and volume, temperature and pressure. That relations also it mentioned. Right? Another one is mentioned in the syllabus. Or entropy is a state function, and also another one is entropy change for the variation of the temperature and volume, entropy change for the variation of the temperature and pressure. The equations also it is you have to discuss here in this point of view. Right? Variation of the entropy or change in entropy with the variation of the temperature and volume, variation of the temperature and pressure is also mentioned in the syllabus. That means it is particularly not mentioned, but you can study it along with this. Entropy changes for various processes mentioned, that in that process you can study that. You can study that. Next one is mentioned in the syllabus. Third law of thermodynamics. So before third law, he was also mentioned entropy changes for isolated systems, and phase transformation it may takes place. Entropy changes for transition of the phase or the physical change it may takes place. For solid to liquid, if it is takes place, what will be happen? And liquid to vapor form it may takes place, or solid to vapor form it may takes place. What it will be entropy change, it is mentioned in the syllabus. Right? All entropy related changes you have to study that. You must study that. And another one mentioned in the syllabus, entropy change. Before that entropy change, third law of thermodynamics is mentioned, another one. So that means you studied the first law, second law, third law. So in addition to the zeroth law is also there, you can follow that zeroth law is also what? Though it is not mentioned, right? First law, second law, third law of thermodynamics also you can study that. Based on the third law, you can calculate the absolute entropies of solids, liquids and gases. Solids, liquids as well as gases are in the vapor form. Absolute entropy of solids, liquids and gases from the heat capacity data. From heat capacity data, D by third law we are using. So from this third law, absolute entropy can be determined of the solids, liquids as well as the gases. Absolute entropy based on this third law, as well as absolute entropy of from the heat capacity data of these solids, liquids, gases. Absolute entropies are what? Right? This is one concept. And also further, entropy change or entropy change in equilibrium and spontaneous process. Equilibrium as well as spontaneity or spontaneous. Equilibrium and spontaneous. So equilibrium process, entropy change in equilibrium means here it is reversible, you may expect that. Entropy change in reversible process is what? And all spontaneous processes are irreversible. In all irreversible processes are spontaneous. Based on that, in all irreversible processes are spontaneous. That means, so equilibrium or spontaneous means you may study the reversible and irreversible process. What is the condition for the entropy change in reversible and irreversible process? And Clausius inequality statement is what? Clausius inequality statement is what? Classius inequality statement is for the equilibrium and spontaneous purpose. Reversible and irreversible purpose, Classius inequality statement is what? And driving force for a reaction is what? Driving force for a spontaneous reaction. This is a statement, driving force for a spontaneous reaction. Driving force for a spontaneous reaction is what? That is also mentioned in the syllabus. Along with this, and mentioned in the syllabus, absolute entropy. Standard entropy. Standard entropy. And standard entropy change for a chemical reaction. Standard entropy change for a chemical reaction. Standard entropy is what? And standard entropy change for a chemical reaction is what? Based on that, problems also there. Standard entropy and entropy change for a chemical reaction. Up to this, mention the concept which is related to the entropy. Entropy related concepts. All these are entropy related concepts. Right? One is which one? First law, second law review. Next, entropy related concept. You can take the entropy. Entropy is a state function, and state function of temperature and pressure and temperature and value. And entropy change for the ideal gases is what? For various processes, the ideal gases. Isothermal is what? Isobaric is pos. What is that? Isochoric process, if it is there, what is the entropy change for ideal gases? And if it is adiabatic process is there, what it will be happening? And entropy change for the mixing of ideal gases, if it takes place, what it will be happening? And entropy changes for the phase constant, it may be takes place. Though if we cannot discuss, but here it is, it may be used. In the absolute entropies of the, it is not directly mentioned the phase constant, but why it is used, we are discussing takes place in the absolute entropy calculation of the liquids and gases, we are using that physical change if it is takes place. So that's why entropy change of the phase change, it may be that physical phase it may be changing takes place from solid to liquid and liquid to solid to vapor. If it is takes place, what it will be happening, right? And one allotrope form to another allotrope form also it may be takes place. What it will be happening, we have to check them. Entropy changes, right? Entropy change for physical change, physical phase change. Physical change means phase change. Phase it means solid to liquid, like that. Liquid to vapor or solid to vapor, like that. Right? After then you have to study then entropy change with variation of the temperature and volume. If it is takes place, what will be happen? Temperature value T1 to T2, V1 to V2. What it will be happening? Entropy change equation is what? And T1 to T2 and P1 to P2. If it is changing takes place, what it will be the entropy change for a system? So you can take the temperature is T1, initial temperature, initial pressure is P1. While pressure is raised from T1 to T2, P1 to P2, what is entropy change? Variation of the temperature and volume, temperature and pressure, it may be equations also there. How to study that. After that, you studied the third law of thermodynamics. Based on third law of thermodynamics, absolute entropy you have to calculate from the heat capacity data of the solids, liquids and gases. And entropy changes for the equilibrium and spontaneous process or the reversible and irreversible process. Based on that, Classius inequality statement is there. And driving force for a spontaneous reaction is what? And standard entropies and the standard entropy change for a chemical reaction. Right? So this is for the concept of the entropy. Next, which is mentioned in the syllabus based on the entropy, another one is Gibbs relationship mentioned. Gibbs. So that means free energy relations, another one is mentioned. Free energy relations. This is the entropy concept. One is for the entropy concept, another one is for the free energy. There are two types of free energies mentioned in the syllabus, Gibbs free energy as well as Helmholtz free energy. Gibbs as well as Helmholtz free energy is mentioned in the syllabus. What it is Gibbs free energy and Helmholtz free energy? That means work functions it mentioned. Helmholtz work function, Gibbs work function and its significance. So next one is based on the free energy work. So he was mentioned Gibbs free energy, syllabus, G and Helmholtz free energy. Gibbs free energy and Helmholtz free energy, and its significances also it is mentioned, and its physical significances. What is G and what is A, and what is delta G relations with delta H and delta S, and delta A relation with E, delta E as well as delta S relations, right? So delta G also, delta A also, here in this point of view we can studying that based on the first law we are using. Everywhere first law of thermodynamics we are using. Everywhere we are using. We are repeating that first law of thermodynamics, the entropy concept as well as the free energy concepts also. Gibbs free energy as well as Helmholtz free energy is there. After then Helmholtz free energy and Gibbs free energy, further the concepts which is mentioned after the free energy, it is mentioned. So Gibbs-Helmholtz equation. Gibbs-Helmholtz equation. Combined Gibbs and Gibbs-Helmholtz equation, it is mentioned in the syllabus. Gibbs-Helmholtz equation. Before that Gibbs-Helmholtz equation, he was also mentioned here in this point of view. Free energy, how the free energy, I mentioned that change in free energy, that means G change in Gibbs free energy with temperature. Variation of the temperature with free energy, and variation of the pressure with free energy. Variation of the temperature takes place and variation of the pressure takes place. How it will be related with the free energy, right? G, temperature dependence G and pressure dependence G, it is mentioned in the syllabus. Temperature dependence free energy as well as pressure dependence free energy. So that means how the temperature variation takes place, how the pressure variation takes place, free energy can be variation, because this Gibbs free energy depends upon the temperature as well as pressure. That means it constant temperature and pressure should be mentioned. So T and P, and here it is Helmholtz free energy is there, E and B, and T and P, and T and V here in this particular point of view, right? How the temperature variation takes place, the free energy's variation takes place, how the volume is variation takes place, the free energy, Helmholtz free energies variation takes place, another one is also mentioned. That means if it is not mentioned, though you can study it, that temperature dependence and pressure dependence G is mentioned means you can also study it, A also, right? Further Gibbs-Helmholtz equation, combined Gibbs and Helmholtz, that equations will be there. Based on the Gibbs-Helmholtz equation, you can study how to calculate the E0 cell and its applications also there. How to calculate the E0 cell. Based on the E0 cell, and delta G relations are what? Delta H relations are what from the E0 cell, and delta S relations are what also, how, and delta A is also how to calculate, how it will be related with the E0 cells, that is also there in the syllabus point of view. But I mentioned this one I can discuss it in the electrochemistry point of view, because with respect to the E0 cell, right? Already I uploaded that video also, right? And another one in the free energy case, Gibbs-Helmholtz equation. Based on the combined Gibbs and Helmholtz, there are 4 Gibbs equations which are proposed. 4 Gibbs equations. Based on the 4 Gibbs equations, one is for the delta G, another one is for the delta A, another one is for the delta H, another one is for the delta E. Based on these 4 Gibbs equations, these Gibbs equations for closed and equilibrium systems. Closed and equilibrium systems. For closed and equilibrium systems, there are 4 Gibbs equations which are there. 4 Gibbs equations are there. Closed and equilibrium systems. Closed system as well as equilibrium, right? Open and non-equilibrium systems, other Gibbs equations also there, right? Based on these Gibbs equations, Maxwell equations are there. Maxwell relations are there. And also 4 Maxwell relations which will be proposed based on the 4 Gibbs equations. 4 Maxwell relations are there. And also thermodynamic equations of the first state is what? Thermodynamic equation of first state, and thermodynamic equation of second state, it may be there. Relations also there. Thermodynamic equation of first state and thermodynamic equation of the second state. Right? And also here in this purpose we can discuss some of the CP-CV relations also. We can discuss here in this particular case based on the first law of thermodynamics, and its some other relations, right? So this is for the Gibbs-Helmholtz equations point of view. Gibbs-Helmholtz equations point of view, Gibbs equations closed and in this particular concept, another is mentioned in the syllabus, free energy changes. That means either the Gibbs free energy as Helmholtz free energy. Free energy changes in equilibrium and spontaneous, like the earlier one, entropy change in equilibrium and spontaneous. Here it is also free energy change in equilibrium and spontaneous. Equilibrium means here it is reversible and spontaneous means irreversible. What is the free energy change in reversible and irreversible process? What is its criteria? Right? What is delta G, delta A? Delta G is equal to delta H minus T delta S. Based on the delta H and delta S plus signs means here it is either it may be the positive value or negative value. Based on the positive value, negative value of the delta H and delta S, how this free energy change takes place, Gibbs free energy. Based on the delta A is equal to delta E minus T delta S, delta E as well as delta S. Based on these two signs, either it may be the positive and negative, what it will be the change of the Helmholtz free energy, right? So that means spontaneous and equilibrium. That means irreversible and reversible process, what will be happening? Spontaneous, non-spontaneous cases. Spontaneous and non-spontaneous case also it may be what will happen, and reversible process also what will be happen, reversible and irreversible. In addition to this, delta A condition is what? Sorry, delta H condition is what? And delta E condition is what? Delta S condition is what? Delta E, delta H, delta S also, delta G, delta H, delta S, all those we can study at one place. For the spontaneous and non-spontaneous process is what? Which one factors is relating, either greater than 0 or less than 0, or if it is minus or plus. Delta S is positive, spontaneous, but delta G is equal to negative, spontaneous. Right? All those we can discuss in this point of view. That classical inequality statement, again we have to apply this. Classical inequality statement, again we have to apply that. And based on the free energy change, chemical potential is what? Chemical potential. Based on the free energy change, chemical potential is also mentioned in the syllabus, right? And another one is mentioned in the syllabus. Based on the chemical potential, it's over and free energy relations are over, and is also mentioned Gibbs equations for open and non-equilibrium systems. Non-equilibrium systems, open and non-equilibrium. Here it is closed and Gibbs equations for closed and equilibrium systems. Here it is 4 equations are there. In addition to these 4 equations, if it is open system and non-equilibrium system, some terms will be added. That is also there in the Gibbs equation. Again 4 Gibbs equations are there. And for this purpose, it is not mentioned in the syllabus, but you discuss the partial molar properties or what? There are partial molar properties are there. That one also useful here in this particular purpose, open and non-equilibrium purpose, and particularly Gibbs-Duhem equation also you have to study that. Though it is not mentioned, but these two are also you have to study that. Partial molar properties and Gibbs-Duhem equation for open and non-equilibrium systems. Gibbs equations, right? And another one which is mentioned in the syllabus for the thermodynamics. Thermodynamics, what it is mentioned, thermodynamics, in addition to this, 1 or 2 little bit it is mentioned. And chemical potential definition is mentioned here based on the delta G, delta A, and chemical potential for ideal gas is what? Is mentioned, chemical potential for ideal gas. Chemical potential for ideal gas is what? And how it is related with the temperature, how it is related with the pressure also it may be given. Chemical potential, how it is related with temperature is also mentioned. Though it is not mentioned, but you can study that along with this. Chemical potential of the ideal gas it may be mentioned. And another one is mentioned phase equilibrium and material equilibrium. Phase equilibrium and material equilibrium conditions. Phase equilibrium condition is what? Material equilibrium condition is what is mentioned in the syllabus. Phase equilibrium as well as material equilibrium. And the last one is mentioned in the syllabus along with the phase equilibrium and chemical phase equilibrium. Clapeyron equation is there, and Clausius-Clapeyron equation is mentioned. Clapeyron equation and Clausius-Clapeyron. What is Clapeyron and Clausius-Clapeyron equations, and how the relations are there, and graphs also it may be there. That is also mentioned in the syllabus. And the last one which is mentioned in the syllabus after the Clapeyron as well as Clausius-Clapeyron equation, Clausius-Clapeyron equation, this in the syllabus mentioned want of equation or Gibbs-Helmholtz equation. So that means with the Gibbs-Helmholtz equation, the calculation of the equilibrium constant concept is mentioned for equilibrium constant. For equilibrium reactions, equilibrium constant. And this equilibrium constant, how it will be depending with the temperature. Equilibrium constant, how it will be depends with the temperature. That means, well, temperature is variation takes place T1 to T2 and equilibrium constant K1 to K2. If it is variation takes place, here it is want of proposed one relation. Want of equation for equilibrium constant and temperature. Want of equation is there. Log K2 by K1 is equal. Equilibrium constant is K2, K1 for certain reactions. And variation of the temperature takes place T1 to T2. And calculation of the delta H, how it will be calculated. That the equation is also there. Log K2 by K1 is equal to delta H by 2.303 R. T2 minus T1 by T1 T2. Some relations will be there, and graphical point of view also the questions will be there. This is the calculation of the equilibrium constant, and how it will be depends upon the temperature. That will be explained by the want of equation. Want of equation. Right. This is the thermodynamic syllabus is mentioned. One is for the first law, second law. Another one is for the concept of the entropy related. Another one concept is for the free energy relation, free energy concept. Entropy and its changes, all it mentioned on place. And free energy, all its changes at one place. Right? You can read the syllabus also based on that. And another one it is mentioned in addition to that, chemical potential terms also mentioned. Chemical potential is mentioned, and closed and equilibrium is what, and open and non-equilibrium systems are what changes it may be happening, and Maxwell relations and some other things will be mentioned. All this unit, complete unit, this thermodynamic complete unit, I was uploaded in the RR Chemistry app. Was complete unit. This complete concepts will be uploaded as per the syllabus in RR Chemistry app. So I can download the app and watch the free video contents. Watch the free video contents also there. You can nearly for 15-16 videos. Videos will be free video content is there in my app, RR Chemistry app. So you can watch that free video content also. Based on that, you can choose whether you have to buy the course or not. JLPL Chemistry, right? Chemistry course is that we complete videos and its related problems also. I'll upload the previous problems and previous CSR problems, net problems, and also the JL, DL, PL examination problems, some other model problems. I already uploaded that, right? This thermodynamics, this is the syllabus mentioned in the thermodynamics unit. Next one unit is what? Next one unit mentioned in the syllabus is the electrochemistry. Electrochemistry mentioned in unit. Fourth unit in physical chemistry mentioned is electrochemistry. Electrochemistry. What it is mentioned in the electrochemistry? So it is also PG level it may mention, but basics also mention it at one sentence just was mentioned. Conductance and its applications. Just one sentence, conductance and its applications. Which means what you have to study that. What is conductance and specific conductance? You read the specific conductance as well as the molar conductance, as well as the equivalent conductance and transport numbers. All those you can study here in this place. Conductance, its applications mentioned, basics. Just one sentence was mentioned in the syllabus, but you read the specific conductance, molar conductance, equivalent conductance, and transport numbers. And also Kohlrausch law. Its applications. All those you have to study that. Cole-Rest law and its applications, and based on this, problems also there, that will also you have to study that, conductance in applications. And further he was mentioned in the syllabus after that, Nernst equation, derivation of the Nernst equation. Nernst equation, derivation is mentioned. Based on the Nernst equation, problems will be definitely is there, how to calculate the E cell. For that, E0 cell calculation is necessary, how to calculate the E0 cell. And equilibrium constant is how to calculate that. So many reactions it is there for the so many of the examples as well as problems are there for the E cell point of view. Nernst equation and its problems it may be there. Right? Nernst equation related. Derivation of the Nernst equation is mentioned. Based on the Nernst equation, further this classification of the cells will be given. Classification of the cells mentioned. Based on the classification of the cells, here it is mentioned. Here it is chemical cells, concentration cells. Classification of the cells will be mentioned in syllabus. Chemical cells is mentioned in the syllabus, and concentration cells will be mentioned. Chemical cells as well as concentration cells. Further, these chemical cells with transference, if it is transference is there, what will happen? With transference, chemical cells, and without transference, chemical cells. Without transference, chemical cells, with transference. So many number of examples are there. Cell notations will be given. What is the E0 cell value, E cell value for the with transference, without transference. You can identify that is chemical cell or concentration cell, with transference or without transference, how to calculate the E cell values. And its E cell values, since concentration is related with the activities also, activity coefficients like that it may be there. Further I mentioned that, see, according to the syllabus is mentioned. Activities also it may be related with the, if it is electrolyte, we can use the activities also. You can use the activities because solute is electrolyte here in this case, in electrochemistry. With transference, without transference. Without is mentioned. Without is what in syllabus? With transference, without transference. How to calculate the E cell values for the chemical cells. Concentration cells is mentioned. Further, these concentration cells are with respect to the electrode concentration cells, and with respect to the electrolyte concentration cells. Electrolyte concentration cell. Just mentioned in the concentration cell with without. Further, you go for that electrode concentration cell, electrolyte concentration cell. Electrode concentration cell with without, and here it is electrolyte concentration cells with transference and without transference. With transference and without transference. Electrolyte concentration cells with transference, without transference, and electrode concentration cells. In all those cases, E0, E cell will be calculated. Like this Nernst equations, you have to apply that. E cell is what? Cell notations are given. I already uploaded that clear videos in the app, or chemistry app. This is entirely different concept. Directly cell notation is given. Based on that, you have to identify that whether it is electrolyte cell or concentration cell or electrochemical cell, particularly concentration cell without transference or with transference, or electrolyte concentration or electrolyte concentration. Here it is also with transference, without transference in the chemical cells. Based on that, you can calculate the E cell values. Right? Next, another one is mentioned in the syllabus, liquid junction potential. Liquid junction potential. Concept was mentioned. Liquid junction potential, how to calculate that, means expression of the liquid junction potential, EJ value, how to express that. What is the liquid junction potential value? Based on the with transference, without transference also, how it is related with the liquid junction potential. And what is the liquid junction potential causes, how it will be the elimination takes place. What is the causes for the liquid junction potential, or how to determine the liquid junction potential. Expression and determine the liquid junction potential, how to determine the liquid junction potential, and how to eliminate the liquid junction potential also. Its determination and elimination. And in this particular case, we are using this with transference, without transference says. it is interrelated. It is interrelated. Right? This is one concept was mentioned in the syllabus. And another one based on the applications of the EMF measurements. So you have to calculate the E cell values in all those cases by applying the Nernst equations and chemical cells and liquid junction potentials. Application of EMF measurements was mentioned. Application of EMF measurements. Further, in the application of the EMF measurements, in these applications mention how to determine the solubility product. That means in this particular case, you have to study what is solubility product, and for the different electrolytes, 1:1, 1:2, 2:3, or what different electrolytes case, how to determine the solubility product, and relation with the solubility product and solubility is what. And also with respect to the E cell, right, EMF values, how it is related with the solubility. That is also there with respect to the EMF. Application of the EMF and solubility product relations are what? That one also you have to study that. And further, this further this potentiometric reactions, potentiometric titrations. So the applications of the EMF measurements, further it may be potentiometric titrations. In the potentiometric titrations, what you have to study that? Acid-base titrations, you have to study that. Potentiometric mentioned just syllabus, but you can study the acid-base titrations and precipitation titrations and acid-base titrations. You must study that. Precipitation also you must study that. Acid-base as well as precipitation you can study it. You can read that. In acid-base, based on the indicator electrode, based on the indicator electrode. In acid base also, strong acid, strong base is what, which type of curves will be obtained. In the examination point of view, based on the graphs, sometimes maybe questions will be there. Potentiometric titrations in the earlier one. And endpoint, based on the endpoint also, questions will be there. And at endpoint, what will be happening, sudden changes if it is happening in the EMF measurements. That is also mentioned in the syllabus, in the examinations point of view. Some graphs also we have to discuss here in this particular case. Potentiometric titrations are there. Like that in the earlier one also, de-vehicle theories case also, it may be having its limitations and validity case also, 1:1 electrolyte, 2:2 electrolyte, 2:1 electrolyte, or 2:2 electrolyte, 2:3 electrolyte, what it will be happening. And graphical point of view questions also definitely there. Based on the acid-base titration, based on the indicator electrode, reference electrode, indicator electrode. Reference electrode is common. Indicator electrode, based on the indicator electrode, if it is hydrogen electrode, if we can take it as indicator electrode, what will be happening? How to calculate the E cell value? And if it is twin hydrogen electrode, if it is there, how to calculate that electrode E cell value? And if it is glass electrode, you can use how to calculate the E cell value, and its related problems also there in the examination point of view. And precipitation electrode, precipitation titration is going to express. And another one more is also there, redox titrations. In the precipitation, in the potentiometric titrations, redox titrations also you have to study that. In the potentiometric acid base, precipitation and redox, you must study that these three. Mentioned in syllabus is just potentiometric titration. In the applications of the EMF measurement, another one you study, another one you can study. You must read that. The another one is, as mentioned in the syllabus, is transport numbers. Determination of transport numbers. That means transport numbers is, you can study here in this particular point of conductance and its applications point of view. This transport number is different. That means though it is transport number, but this transport number, how it is related with EMF measurement. By using the EMF values, E cell values, how can you determine the transport number? That one is, you have to study that. The solubility product also it related with EMF is what? And general solubility product questions also there. So that's why you read the solubility product. Saturated solution is what? Right? In the precipitation, if it is formation takes place, what will be happen? Unsaturated solutions are what? All those you can study that. And transport number, another one is the how to calculate the equilibrium constants. Equilibrium constant by using the EMF values and equilibrium constant relations are what? Right? So this is in the applications of the EMF measurement. You must read this, all those. Right? In addition to this, if it is electrochemistry generalized acid base conductometric titrations, you can read that. Conductometric titrations of the acid base and curves, it is important. Different acids and different bases. So acids and bases, if it is, strength of the acid and strength of the base can be depending upon the weak and strong. Weak acid, weak base. Strong acid, strong base. Right? If it is weak acid, strong base, if it is takes place. Right? Weak base, strong acid, if it is takes place, what will be happen? Conductometric titrations also, you must read that. This is the one of the case in the electrochemistry point of view. And I mentioned in another one, in the electrochemistry, in addition to this, liquid is a EMF measurement. So this is the cells, chemical cells, Nernst equations, and chemical cells, concentration cells, liquid junction potential related, and EMF related. And another one was mentioned in the syllabus, electrode polarization. Electrode polarization. Why polarization takes place at the electrode, what it is causes, and how it can be eliminated. How it can be eliminated. Right? Electrode polarization and its eliminations. Why it is happening, that it causes eliminations, is mentioned in the syllabus. Electrode polarization. Electrode polarization and its causes and its eliminations. And its elimination is mentioned in the syllabus. And decomposition potential is mentioned. Decomposition potential is what? Decomposition potential and its significance. And another one, over voltage. Another one in this particular case, concentrated over voltage or over potential is mentioned. Concentrated over potential, over voltage is mentioned. That means before concentrated voltage, what is over voltage? Over potential, you must read that. Then concentrated over voltage is what, or concentrated over potential is what? Right? And how it is related, that factors which are affecting on the over potential also, you must read that in this particular point of view. Right? This is another one concept mentioned in the syllabus. Electrode potential, decomposition potential, over potential in this particular case. And further is the de Baekel concepts which is mentioned. De Baekel theory of electrolyte solutions. De Baekel theory of electrolyte solutions. Electrolyte solutions. If the solute is electrolyte, de Baekel theory of electrolyte solutions are what? And its limitations and applications. Its limitations and applications is mentioned. De Baekel theory of electrolyte solutions and its limitations and applications, and de Baekel limiting law. De Baekel limiting law. De Baekel limiting law. And its validity and applications, and how this in these particular applications, how it is related with the mean activity, mean ionic activity coefficient, mean ionic activity coefficient, gamma plus or minus, how it is related with the de Baekel limiting law, mean ionic activity coefficient. That means mean ionic activity coefficient means here is mentioned in the syllabus. In this particular concept, what is activity A and mean ionic activity A plus or minus is what, and activity coefficient is gamma, and mean ionic activity coefficient gamma plus or minus. Here it is mean ionic activity coefficient, how it is related with de Baekel limiting law. That it will be mentioned in the syllabus. Right, activity is what? Mean ionic activity is what? Activity coefficient is what? Mean ionic activity coefficients are what? How to calculate for the different electrolytes, that it will be also there. And this activities and its activity coefficients related with the E cells. So that means cell without transference, with transference case also we are using this. So that's why before E cell, before concentration cells, chemical cells, I'm explaining the concept in the app, because that will be used in the particular electro E cells point of different types of cells point of view, and in this context we are using. So that's why I'm explaining in the app very beginning one this concept is explaining. Right? And here in this context also, you can also studying the ionic strength is what? Ionic strength I or mu we are using. Ionic strength is what? Some equations will be there. For 1:1 electrolyte, 2:1 electrolyte, or 1:3 electrolyte, or 2:3 electrolyte, different types of electrolytes, how to calculate the ionic strength values. Because this ionic strength also it may be related with this, the de-Becquerel concept. Right? De-Becquerel theory and de-Becquerel limiting law. Further, based on its limitations and validity, extended de-Becquerel limiting law is also there. Extended de-Becquerel theory is also there. De-Becquerel theory will be extended. Extended de-Becquerel law or extended de-Becquerel theory is there. Extended de-Becquerel theory. And next mentioned in the syllabus, theory of electrolyte conductance. Theory of electrolytic conductance. Electrolytic conductance. Theory of electrolytic conductance. In this theory of electrolytic conductance, particularly mentioned in the syllabus, de-Becquerel-Onsager equation. De-Becquerel-Onsager equation. Derivation of the de-Becquerel-Onsager equation is mentioned in the syllabus. Derivation of the de-Becquerel-Onsager equation. Based on which concept? Relaxation effect and electrophoretic effect. Relaxation effect and electrophoretic effect. This de-Becquerel-Onsager equation will be derivation takes place. And it's related with the concentration, either the equivalent conductance or molar conductance, how it is related with the concentration. And graphs also there in this particular point of view, it is useful, de-Becquerel-Onsager equation and its validity and limitations also. And its validity and limitations also there in the syllabus. And particularly graphs is also there, equivalent conductance as well as molar conductance, how it is related with the concentration, different curves also there. Right? That is also there in the examination point of view, it is important. And after the de-Becquerel theory, right, and de-Becquerel limiting laws, extended laws, all those, next mentioned in the concept of the ion association. In the syllabus mentioned as the ion association. For this ion association, B.J.Rrm was proposed one theory based on the scientist name B.J.Rrm. So B.J.Rrm theory of ion association, and association constant is what? Ion association and ion association constant. Ion association and ion association constant. Based on this limitations, this concept will be proposed. Association takes place, what will be happen? And in the case of dissociation constant, as also you can study that and how it is related with the dissociation constant and association constant. That one also it is important here in this case. And B.J.Rrm theory of ion association constant. And further, the last one is mentioned. D/by and B.J.Rrm concept is what? De-Becquerel and B.J.Rrm concept is what? For ion association. D/by and B.J.Rrm concept of the ion association. D/by and J.Rrm concepts of the ion association. This is the electrochemistry mentioned in this syllabus. Electrochemistry. Right? Conductance and its applications. Basics, all those you have to study that. Equivalent, molar, specific conductance, and Coleridge law, transport numbers and its applications, all those you have to study that. Right, at one place and its related problems. Further, derivation of the Nernst equation. And for that, so many problems it may be there. And based on that E cell values, chemical cells and concentration cells, cells are different types and with transference, without transference. Right? E cell values, how to determine that? That is important concept. Most of the questions you may also expect that. And from the liquid junction potential also you may expect that questions. In the area of the liquid junction potential, questions also there. And how it is elimination, how it is determined, and how it is related with the earlier concepts of the with transference, without transference. Further, determine the applications of the EMF measurement, how to determine the solubility product and potentiometric titrations as well as the transport numbers and equilibrium constants. Further, electrode polarization and how it is happening and what is the reasons and how to eliminate it, and decomposition potential and concentrated over potential or over voltage, This is the one concept. And for the de-Becquerel theory of the electrolytic solutions and its limitations, applications, and for the de-Becquerel limiting law says what and how it will be evaluated and applications, and it's related with the mean ionic coefficient is what, mean ionic activity coefficient, how it is related, and this relation extended to the ionic strength of the solutions. And what is activity? Activity coefficient is what? Mean ionic activity is what? And mean ionic activity coefficient is what? Further, this extended de-Becquerel theory is there based on these failures. Further, electrolytic theory of conductance is there, that is proposed by de-Becquerel. De-Becquerel is proposed on one equation, derivation of the de-Becquerel-Onsager equation based on the relaxation and electrophoretic effects. Electrophoretic effects and its validity and limitations. The last one it may be mentioned in the syllabus, ion association and Bigeron theory of the ion association constant, and de-Becquerel-Bigeron theory combined relation for the ion association concept. This is the electrochemistry syllabus is mentioned, electrochemistry point of view syllabus is mentioned. This complete unit I was uploaded in the RR Chemistry app. Complete unit, complete topics will be discussion takes place already, completely, right? And good HD quality videos also recorded, and problems, so many problems, previous problems of the CSR, NET, GATE, and JL, DL, of most of the problems already I am discussing that in this particular concept, electrochemistry concept. Right? Next unit is the physical chemistry. Fifth unit mentioned in the JLPL chemistry syllabus, quantum mechanics. Quantum mechanics. In this quantum mechanics, first mention the basics of the degree level. Right? So what it is mentioned in the quantum mechanics? Black body radiation. Black body radiation was mentioned. Black body radiation. And after the black body radiation and was mentioned Planck's theory, Planck's theory or Planck's concept, and how it is related with the black body radiation, and quantization of the Planck's theory and Planck's quantization concept. Quantization. Planck's quantization and Planck's equations. After then, average energy of the oscillator as the Planck. How to calculate the average energy of an oscillator. So this is the Planck's theory. For Planck's theory, this average energy is the new concept considered to the earlier degree level concept. Right? Planck's theory is what? And quantization of the Planck's theory and average energy of an oscillator, how to obtain that. Based on this also, average energy also earlier questions also there. And another one which is mentioned in the syllabus, after the Planck's theory, wave particle duality mentioned in the syllabus. Wave particle duality means this was mentioned by the, which one? De Broglie. So that means de Broglie hypothesis you must read for the wave particle duality. And in addition to this, photoelectric effect also you must be studied that. Photoelectric effect phenomena also you can study, because somewhere we are using. For the wave particle duality point of view, we are using this photoelectric concept also. For the dual nature of mass or matter case, we are using this photoelectric phenomena also. So de Broglie hypothesis you must read that. And also mention uncertainty principle, another one. Uncertainty principle. De Broglie concept and uncertainty principle is what? Which one is proposed by the uncertainty principle? Heisenberg. That means Heisenberg uncertainty principles are what? And its related problems. You must read that. These four concepts. And further, it was mentioned in the syllabus, emergence of the quantum mechanics. Emergence of the quantum mechanics. How the quantum mechanics was introduced, why it is introduced, the earlier classical mechanics, why it is failure. Emergence of the quantum mechanics and What is the wave mechanics? Wave mechanics is what? And quantum mechanics are what? And for quantum mechanics, particularly for the microscopic entities, this quantum mechanics, microscopic particles point of view, quantum mechanics is introduced to explain the properties of the microscopic objects, particularly small size particles. Earlier classical mechanics is failures. And based on this, Schrödinger wave equation is also proposed. Schrödinger wave equation is what? This one is also mentioned in the syllabus. This is the quantum mechanics syllabus, it was mentioned. Schrödinger wave equation is also. Up to this is over. This is the one concept, one type of concept. Further it is mentioned in the syllabus operators algebra. In this operators algebra, you must know that what is an operator and how to the multiplying the operators, multiplication of the operators, you must read that, and commutation operator or commutative operators. So many problems are there for the commutative operators related, and linear operator is also mentioned, another one. Commutative operator, linear operator, and how to multiplying the operators. That will be mentioned in the syllabus, in the operators algebra point of view. In addition to this, complex functions are what is mentioned. Complex functions. And another one more is mentioned in the syllabus, eigenvalues and eigenfunctions. That means eigenfunctions. If a function is eigenfunction with respect to an operator, you can calculate the eigenvalue. This is the most important. Further, it may be useful for the entire quantum mechanics. Eigenvalues and eigenfunctions. This is one concept it was mentioned, and further it was mentioned well-behaved or acceptable functions. Well-behaved functions. It was mentioned in syllabus is well-behaved. That well-behaved functions also called as acceptable functions. Some conditions will be there, right? That conditions will be when a wave function must follows that condition. That function is well-behaved or acceptable functions. After then, normalization condition is mentioned. Normalization condition or normalized wave function is what? And orthogonal condition or orthogonal wave function. Normalization condition and orthogonal condition, another one is mentioned. Normalized function and orthogonal functions also. Well-behaved, normalized and orthogonal. These three also mentioned in syllabus. Right? And another, this is one case, he was mentioned, that particular case he was mentioned in the syllabus. So this in quantum mechanics, particularly problematic related questions are so many is there. Right? Particularly in the operators point of view, so many questions will be generated. Commutation operator related and linear operator. And also Hermitian operator is also mentioned. In addition to that, another one operator, Hermitian operator is also mentioned, important. Hermitian operator. Theories are not mentioned, but in the point of view the Hermitian operator, theories also involves. So that's why theories of the quantum mechanics also you must read that. Hermitian operator is what? And another one is mentioned in the linear combination of eigenfunctions is an operator. He was mentioned. Linear combination of eigenfunctions is an operator. This is also some sort of theory, it may be there. Particular sentence he was mentioned in the syllabus. What it is, that meaning of the sentence, linear combination of the eigenfunctions is an operator. Linear combination of an eigenfunction is an operator. That will be also I can explain. Right? This is the operators related and wave functions and normalization, well-behaved functions and eigenfunctions, eigenvalues, normalized functions and orthogonal functions related, it may be there. And another one mentioned in the syllabus, postulates in the quantum mechanics. Postulates in the quantum mechanics. There are 5 postulates are there in the quantum mechanics. First postulate was mentioned in the syllabus, interpretation of the wave function. Interpretation of wave function psi. Interpretation of the wave function. That is the first postulate is mentioned in the syllabus is interpretation of wave function. And second postulate is explains that when you know the wave function, you know that the operator, And for relating property, suppose energy is there, how it is related, how it can be shown the quantum mechanics with respect to that operator. Momentum, what is an operator in the quantum mechanics? How can you express that? So that means physical observable properties, observables, and in terms of quantum mechanics, how it is related, expressed with the operators. So second one is mentioned, second postulate related, observable and operators is mentioned in the sentence in the syllabus. And with related to the third operator, third one postulate, and how this observable properties will be mentioned in the form of operators. So measurability of the operators mentioned in the, with related to the third postulate, syllabus was mentioned, measurability of operators. And fourth postulate mentioned in the syllabus, the measurability of operator, if the function is given function is eigenfunction, in the form of eigenvalue we can measure. If suppose the function is not an eigenfunction, we can calculate the average value. So average value of observables can be calculated. Some other principles we are using that will be explained by the postulate fourth, that is mentioned in the syllabus. Average value of observable, just line is mentioned, that is postulate fourth. And postulate fifth, what says that time independent Schrodinger wave equation, time independent Schrodinger wave equation, and its separation of the variables. Separation of the variables. How to derive this time independent Schrodinger wave equation and separation of variables, and time dependent Schrodinger wave equation also. Time dependent Schrodinger wave equation. From the time dependent equation, you can propose the time independent Schrodinger wave equation. You can take this time dependent, then time independent Schrodinger wave equation. This is the postulate fifth is mentioned in this syllabus. Right. So this is the quantum mechanics point of view mentioned in the syllabus. Compared to the AP, DL, this quantum in JL and Polytechnic quantum mechanics syllabus is, compared to the DL syllabus, it is less. DL somewhat particle in one dimensional, three dimensional is there, but here it is not mentioned in the JL, PL. Right. But somewhere we are using the wave functions, particle in one dimensional wave function and energies in this particular point of view we are using, but not all those things. Right. Whenever it is required to explain the postulates, we are using that. Right. So this is the quantum mechanics is mentioned in the syllabus. This complete unit also I am uploaded that already I can uploaded in the App-Ravinder app. Complete unit, detailed manner I can explain. I already uploaded that. This entire unit. Right. You can download the App-Ravinder app from the Play Store. Then you can watch the videos. Right. So the syllabus range is different. Syllabus range is different. Very beginning I am explaining that why syllabus, the people of lower level teaching school, or if it is some of them it may be only with particular unit only, they know that. But they are say that they are offering the coachings. How it is possible, I don't know. But if it is possible, when it is possible, so many of the persons are club. Each one it takes one unit. It is not the efficient coaching methods. So it may be, suppose it may be physical is one person, organic is one person, inorganic one person, no problem. Or if I can deal with physical, inorganic, all those, because I have an idea about that. Complete idea about that, all those units in detail. I can justify that. So that's why I can deal with. So this is the physical chemistry of the quantum mechanics unit. Next, another one unit in quantum mechanics. Unit 6th, chemical he was mentioned the theory of reaction rates. Theory of reaction rates was mentioned. Arrhenius theory, you can study that. Theory of reaction rates starts with Arrhenius theory. right? And collision theory was mentioned. Theory of reaction rates, particularly mentioned collision theory. But you can also study that Arrhenius equation. Most number of questions also came from the Arrhenius equations point of view. Theory of reaction rates, Arrhenius theory is also one of the part. And collision theory. Collision theory, you must read the collision theory of unimolecular reactions and bimolecular reactions. The 7th unit mentioned in the syllabus. 7th unit of physical chemistry mentioned in the syllabus. Photochemistry. physical photochemistry. Organic photochemistry, in organic chemistry also, in organic chemistry point of view, photochemistry is mentioned. That is different, and here it is different. But some concepts, it may be same, it may be there. Similarity is there in the concepts. But with respect to the physical properties, these concepts will be there. With respect to the chemical properties or chemical reactions, that organic chemistry point of view is there. In photochemistry, in the physical chemistry, physical point of view, electronic transitions was mentioned. The first one, electronic transitions in molecules. How many, which electronic transitions are possible? Which electronic transitions are possible? Here we can apply the gyroid, ungyroid concepts, and symmetric concepts also we have to apply that, and sigma to sigma star, pi to pi star, n to pi star, n to sigma star. Which one is allowed, which one is not allowed, and how many transitions are possible with respect to the bonding, sigma bonding, pi bonding, non-bonding electrons. All those we can discuss it in this point of electronic transitions of molecule. You may expect that one question in this area. And another one is mentioned in the syllabus based on the electronic excited states of the molecule. Electronic excited states of the molecule. Electronic excited states of molecule. In the electronic excited states of molecule, mention what is singlet state and what is triplet state. In the electronic excited states of the molecule means triplet state is what and singlet state is what. Mention how to determine the, how to say for the particular it may be triplet and particular state it may be having singlet state. This is also mentioned in the syllabus. And another one syllabus is mentioned in the photochemistry point of view, transitions and excited states and Frank-Condon principle. Frank-Condon principle is what is mentioned in the syllabus. This is also principle, just Frank-Condon principle. And based on the excited states of the singlet and triplet states, natural radiative lifetimes of excited states. Radiative lifetimes. That means here in this purpose, what is lifetime and how it is lifetimes can be determined and how it is related with the rate constants. How it is related with the rate constants. And in the radiative lifetimes also it may be two types will be there. Measure radiative lifetimes. Measure radiative lifetimes and natural radiative lifetimes. Based on this also you may expect the questions. Measure radiative lifetimes and natural radiative lifetimes. Further, this measure radiative and natural radiative lifetimes can be used for the fluorescence process and phosphorescence process also. That means in this context, you must read the Jablonski diagram. Jablonski diagram. Jablonski proposed one diagram. In that proposed, Jablonski was explained what is fluorescence process, what is phosphorescence process, what is intersystem crossing, and what is internal conversion. Internal conversion, IC. Intersystem crossing is ISC, fluorescence and phosphorescence, and vibrational relaxation or internal cascade. Vibrational relaxation or internal cascade. These five processes will be explained by the Jablonski. Some of it may be radiative process, some of it may be non-radiative process. Right? Based on these five processes, again we have to discuss the measure radiative lifetimes and natural radiative lifetimes. Based on that also examination point of questions also there. This is one concept was mentioned in the syllabus. And another one, quantum yield and its determination. Quantum yield and its determination. What is quantum yield and how it will be determined? Determination of the quantum yield. What are the reasons for the high quantum yield and low quantum yield? Secondary process are what, primary process are what, and what are the examples? All those you have to study. You can study that, and based on these problems also there, you must expect the question from the problematic point of view based on the quantum yield. Right, in the photochemistry. And also the determination of quantum yield for the fluorescence process, determination of quantum yield of the fluorescence, and determination of quantum yield of phosphorescence. This is separate equations will be there. Determination of the quantum yield of fluorescence and quantum yield of phosphorescence and E-type delayed fluorescence. Another one is mentioned, E-type delayed fluorescence. E-type delayed fluorescence and is eosin by the name of the scientist. First letter E type of delayed fluorescence. Another one, it may be P type delayed fluorescence is also there. Though it is not mentioned, but you have to study that. E type delayed fluorescence or delayed fluorescence are what? E type delayed fluorescence and P type delayed fluorescence. By using that, you can calculate the singlet triplet state energy for the evaluation of triplet state energy. Triplet state energy. For the evaluation of triplet state energy. E type delayed fluorescence and evaluation of triplet state energy. Evaluation of the triplet state energy. That is the one concept is mentioned in the syllabus. And actinometry, mentioned another one concept, actinometry. And these actinometries are two types. Ferrioxalate actinometry is ferrioxalate actinometry and uranyl oxalate actinometry. Uranyl oxalate actinometry. This was mentioned, ferrioxalate actinometry and uranyl oxalate actinometry is there. Two types it may be there. Based on that also, you may expect the question. This concept is simple. I already mentioned this unit. So this, except this unit, remaining all units, almost all units as I was uploaded in this app. This one is also within week. I can plan to upload this. Then you can watch that videos also. Ferrioxalate actinometry and uranyl oxalate actinometries are what? This is some of the concept. And another one concept was mentioned in the syllabus, laws of photochemistry. Laws of photochemistry. You know that Beer's law, Lambert's law, right? And also Grother's-Doppler's law, like that. All those laws you have to study the basics of this quantum mechanics in the laws of photochemistry. Another one is mentioned in the syllabus, photophysical process. Photophysical process. In this particular photophysical process was mentioned photophysical kinetics of unimolecular process. Photophysical kinetics of unimolecular process. This photophysical process are what? Then photophysical kinetics of unimolecular reactions. How to calculate that? Kinetics for the unimolecular reactions. Based on this, calculation of the rate constants. Calculation of rate constants for various photophysical process. For various photophysical process. For various photophysical process are which one? Fluorescence, phosphorescence, intersystem crossing, internal conversion, vibration, relaxation. All those cases you have to calculate the rate constants. Rate constants for the calculation of the rate constants for the various photophysical process. This is the another one concept. And for that, variation of the photophysical rate constants, all those mentioned in one diagram form, that diagram is called as the state diagram. State diagram is also related to this. Photophysical process and photophysical kinetics of unimolecular reactions and calculation of the rate constants for various photophysical process and state diagram. All those is one concept in the photochemistry point of view. All those it is one place. Photophysical kinetics of the unimolecular process. And another one mentioned in the syllabus, some photochemical reactions. Photochemical reactions. But in the organic point of view also mentioned, so need not to discuss this point of view. But whenever the reactions which is related to the physical properties point of view, some examples I can explain that. What is mentioned in the photochemical reactions point of view, photo dissociation reactions it may be mentioned, photo addition reactions is mentioned, and abstraction reactions are mentioned. Dissociation reactions, addition reactions, abstraction reactions, and isomerization reactions. And isomerization reactions was also mentioned in the syllabus, and oxidation reactions also mentioned. Addition reactions, dissociation, abstraction, isomerization, and oxidation reactions. Right? So this type of photochemical reactions also mentioned in the syllabus. Photochemical reactions. In addition to this, one or two it may be also mentioned. Right? Photo dissociation, addition, abstraction, isomerization, oxidation reactions are mentioned in the syllabus. Photochemical reactions. We can also discuss this, but not that much of the organic chemistry photochemistry, organic photochemistry point of view. Right. Next, another one it is mentioned in the syllabus. Calculation of, so that means depending upon the intensity, how it is related with the rate constants, various processes, effect of intensity on rates of the many reactions, effect of intensity, how the intensity of the absorption light with respect to that intensity, right? Effect of intensity and rates of reactions, how it will be influenced on the rates of the reactions. In that particular case, whether the reaction, it may be having different steps, it may be there. Absorption takes place, what will happen based on the termination steps. If secondary steps are setups, what will happen, how it is related. If the termination is biphotonic, multiphotonic, or monophotonic, terphotonic, what it will be happening. All those we can discuss it in this point of view. Effect of light intensity, that particular light intensity is effect of light intensity on rates of reactions. Another one mentioned in the syllabus, photosensitization. This photosensitization also you may expect the questions which is related to the physical point of view. In chemical reactions point of view is also there, and physical examples also there for the photosensitization. What is photosensitization? I can explain what are the examples also there for the photosensitization and explain that. And quenching process, in this case, this quenching is also there in the organic chemistry point of view also, but this physical properties case, physical chemistry point of view also there, but similarity is there, but we can discuss based on the physical process, what is rate constants, like that, not chemical reactions. Quenching process and quenching measurements, by using the Stern-Volmer equation. Stern-Volmer proposed one equation for the quenching. So Stern-Volmer equation for the quenching measurements. Based on this examination point of view, definitely questions are there in most of the DL examination, in DL and PL, JL, Gurukula. Every time questions are there from this quenching measurements and Stern-Volmer equation. And finally, the experimental setup of a photochemical reaction, how the photochemical reaction will be set up experimentally. And another one is mentioned in the syllabus, fast reactions. For studying the fast reactions, flash photolysis technique will be there. Flash photolysis technique. Fast reactions, based on the fast reactions, flash photolysis technique will be there. So this is the photochemistry. This entire unit, so it is at present some sort up to Jagiellonowski diagram and natural radiative lifetimes and electronic properties of the molecules and excited states. Up to that I can upload it already. Somewhat it may be remaining. That one is also within a week I can plan to upload this entire unit. This is the photochemistry in the physical chemistry point of view is mentioned in the syllabus. This is the 7th unit was mentioned in the syllabus, physical chemistry point of view. Most of the questions in the JL, DL in the earlier examinations, minimum 60 to 70 questions are there. Out of 150, 60 to 70 questions are there from the physical process, because the physical chemistry syllabus, because the syllabus range is also wide. Inorganic, some less questions will be there. But physical, so many questions are there because the syllabus is also heavy syllabus. Right? So this is the photochemistry. Another one unit which is mentioned in the syllabus, that one is in the solid state. The last unit is the solid state. Right? And another one last unit which is mentioned in the syllabus, 8th unit is the solid state in physical chemistry. Solid state. As mentioned, first basics of the solid state. That means characteristics of solids was mentioned. Characteristics of solids. So based on the characteristics, solids it may be amorphous and crystalline solids, and you know that amorphous crystalline solids. Another one was mentioned in the syllabus, based on the binding forces. between the atoms based on the binding forces, types of the solids, crystalline solids, types of the crystalline solids based on the binding forces, types of the crystalline. Amorphous you may be rejected, we are not discuss crystalline solids. The crystalline solids, amorphous, crystalline. And for the crystalline, based on the binding forces, how many is there? Covalent solids, ionic solids, and metallic solids, like that. Types of crystalline solids. Further mentioned in the syllabus, based on the structure of the solids, X-ray crystallography. X-ray crystallography based on the structure. X-ray crystallography, in this particular point of view, Brock's equation, you have to discuss that. Brock's equation, X-ray crystallography. Another one you must here in this particular case, another one is mentioned, crystal lattices and unit cells. Lattices, unit cells, and Bravais lattices. For a crystal lattices, what is crystal lattice? Space lattice is what, crystal lattice is what, and Bravais lattices are what? And how many types of crystal systems are there in this particular point of view? You can also study the crystal systems. 7 types of crystal systems are there. You must read that crystal systems. For the crystal systems means, if cubic, rhombic, hexagonal, like that, all it may be there. 7 types it may be there, monoclinic, triclinic, like that. So if you, for the crystal systems, you must study it based on the plane of symmetry, axis of symmetry, and center of symmetry. Plane of symmetry is again, you have to study that diagonal plane of symmetry and rectangular plane of symmetry. And axis of symmetry is also, you may be studied that 4-fold is what, 3-fold is what, and 2-fold is what. So you must know the plane of symmetry and center of symmetry, axis of symmetry, and crystal systems and Bravais lattices. This is crystal lattice point of view, you must study that. And unit cells. And based on the unit cells, types of unit cells, primitive unit cell and centered unit cells are there. Primitive unit cells are there, centered unit cells. In centered unit cells, again, it may be 3 types, it may be there. So face-centered unit cells, body-centered unit cells, and end-face-centered unit cells. Face-centered, body-centered, end-face-centered unit cells, FCC, BCC, FCC or CCP, BCC, and EFCC, end-face-centered unit cells. And also for each one unit cell, how many number of atoms are there? That is also mentioned in the syllabus. Number of atoms calculated for each unit cell. For unit cell, number of atoms are there. How to calculate that number of atoms per unit cell? That is also you must calculate in this point of view. Okay? This is for the unit cells point of view. And further, in the crystal lattices and Bravais lattices, in the Brock's equation, you must know the Miller indices and Weiss indices. And for a particular crystal system, how to calculate the Miller indices based on the Weiss indices. Right? That one is also important for the Miller indices and Weiss indices to represent the system. And further, it may be mentioned also packing fractions or packing efficiency is also mentioned. Packing fraction or packing efficiency is mentioned. That packing fraction or packing efficiency you must study for the unit cells cases also. That means simple unit cell, for that means body centered and face centered and HCP and end face centered. In this every one case, packing fraction efficiency is what? And neighboring atom neighborhood atom distance is also what? So all those we have studied in the packing fraction, packing efficiency, and radius is also what? Right, and it's related, edge lengths are what? So all those we have to study in the case of the packing fraction and packing efficiency of these unit cells. These unit cells again we are using for that case. Packing fraction and packing efficiencies of the solids, we are using that. And based on that, packing fraction, packing efficiency, it's related with the coordination number, and geometry is also there. And radius ratios, in this particular case, we are using the radius ratios and geometry and coordination number. Relations also, radius ratio, cation anion, RC by RA. Based on that cation anion ratio, what is its coordination number and what is its, how it's related with the geometry also we have to discuss in this particular point of view. And also another one is mentioned in the syllabus, density of the unit cells. Density of the unit cells. Which one? Again, it may be simple cubic cells or primitive unit cells, simple cubic unit cells. Another one is centered unit cells, face centered, body centered, end face centered. Case, each one case we have to discuss the density is what? Density of the unit cells. Right, densities, packing fractions, as well as number of atoms per unit cell and Miller indices, Weiss indices, Bragg's equation, and types of crystal systems based on the binding forces. How many types of solids are there? Classification of the solids. All you must read that. That means the basics of the solids, all solids will be mentioned. Basics of the solids. And again, it will be mentioned in the solids based on the packing arrangement of the atoms. Before packing arrangement of, based on the packing arrangement, closed packing arrangements in 1D and 2-dimensional and 3-dimensional. Closed packing arrangement in 1-dimensional, cubic closed packing arrangements in 1-dimensional, 2-dimensional, 3-dimensional is what? Packing arrangement. And based on this packing arrangements of the 1D, 2D, 3D, voids are generated, empty spaces are there. And how many types of voids are there? Tetrahedral voids and octahedral voids. Based on the tetrahedral voids and octahedral voids, you must calculate the formula of the units. That means formula of unit cell also you must calculate. Based on tetrahedral and number of octahedral. And how many octahedral voids, tetrahedral voids are possible per unit cell also. For each one unit cell, how many tetrahedral and number of tetrahedral voids and octahedral voids are how many possible for unit cells also. You must read that voids, tetrahedral, octahedral, and formula units for the octahedral, tetrahedral, and how many number of voids are possible per unit cell also you must discuss in this particular point of view. Voids also mentioned in the syllabus, right? After then, voids mentioned in the syllabus, which one is mentioned? Magnetic properties of the solids. Magnetic properties of the solids is mentioned in another one. Magnetic properties. Magnetic properties was mentioned. Based on the magnetic properties, types of solids. How many types of solids? That means paramagnetic, diamagnetic, ferromagnetic, antiferromagnetic, like that. These different types of solids it may be there based on the magnetic properties. And magnetic susceptibility is what? Magnetic susceptibility. Based on the magnetic susceptibility, also this classification of the magnetic materials takes place. Solids, classification of the solids takes place. Para, dia, and ferro, antiferro, it may be there. I can explain this. I already uploaded this video. And another one which is having, based on the magnetic properties, Langevin is proposed one theory. Langevin theory of diamagnetism. For diamagnetic substances, Langevin is proposed equation, Langevin theory of diamagnetism, and Weiss theory of paramagnetism. Weiss theory of paramagnetism. Curie's-Weiss law. Weiss theory of paramagnetism and Langevin theory of diamagnetism. For paramagnetism, Weiss theory is there, and for diamagnetic properties, Langevin theory is there. That is in the magnetic properties of the solids. This magnetic property of solids, repeated the sentence in the syllabus, 2 times it may be mentioned. But you can exclude that one. This is repeated, solid state point of view. You can exclude that. You can read it as 1. Magnetic property solids, based on the types of solids, based on the magnetic properties and magnetic susceptibility, and Langevin theory of diamagnetism, Weiss theory of paramagnetism. In this point of view, Curie's-Weiss law is there. And temperatures also there, knee temperature, Curie's temperatures, and some sort of graphs is also there. Based on the graphs, which one it may be graph related to the paramagnetic, diamagnetic, and based on which temperature para is going to be dia or dia is going to para is going to be ferri, that it will be also there. Based on that, the questions also there in the previous examinations point of view. Another last one in the electronic properties of the solids. Electronic property of the solids is mentioned in the syllabus. Based on the electronic properties, solids may be classified as the metals, conductors, and semiconductors. This will be explained by the band theory. Electronic properties of solids can be explained by the band theory. Based on the electronic properties, solids it may be metals, conductors, as well as semiconductors. Like electromagnetic properties, para, dia, ferro, like this. Here it is metals, conductors, and semiconductors. Again, semiconductors are 2 types. Based on the impurity or dopant atom, right? Pure semiconductors or intrinsic semiconductors. Another one is extrinsic semiconductors or impure semiconductors. Pure semiconductors are intrinsic, another one is extrinsic or impure semiconductors. Based on the dopant atom, fifth group element or third group element, if it is doping takes place with the external pure semiconductor while taking, if it is dopant takes place for the pure semiconductor, for doping of the impurities takes place, extrinsic or intrinsic semiconductors will be there. Intrinsic and extrinsic semiconductors will be there, another one. So intrinsic or extrinsic or impure semiconductors. Pure semiconductors are intrinsic. Extrinsic semiconductors are impure. Extrinsic semiconductors placed on the dopant atom. Pure semiconductor plus dopant atom is extrinsic semiconductor. So based on the extrinsic semiconductor, again it may be depending upon the dopant atom, N-type and P-type semiconductor. If it is doping with the third group element to the pure semiconductor, P-type, and fifth group element you can add N-type semiconductors are there. P-type and N-type semiconductors. Based on that, holes will be generated and excitons is their concept. Holes, electrons and excitons are there. And how the conductivity takes place in the semiconductors. And depending upon the temperature, how it will be influencing the conductivity of the semiconductor. That is also we can discuss in this point of view. Temperature dependence, conductivity, and temperature dependence, particularly N-type semiconductor and P-type semiconductor. How the temperature will influence on the N-type and P-type semiconductors. That is also there in the syllabus. Effect of the temperature on N-type semiconductor as well as the P-type semiconductor. Right? This is the electronic properties of the solids, which is mentioned in the syllabus. And finally, it may be the photoconductivity and photovoltaic effect will be there. Photoconductivity, photovoltaic effect. This is also, you must read that here in this. Electronic properties of the solids. Electronic properties of the solids. Photoconductivity and photovoltaic effect. Photoconductivity, photovoltaic effect. And once again, I repeated the solid state. Characteristics of solids, amorphous, crystalline. Based on the crystalline solids, types of crystalline solids. Based on the binding forces. Ionic, covalent, molecular solids and metallic solids, that it may be there. And another one is, I remember that defects. Defects in the crystal. Defects in the crystal is also mentioned. Defects in the crystal, two types of defects it may be there. Stoichiometric defects and non-stoichiometric defects. Stoichiometric, that is point defects. Defect it may be a point or defect it may be a plane. But plane defects that it may be eliminated, only point defects, stoichiometric and non-stoichiometric. Stoichiometric it may be Schottky defects is there as well as Frenkel defects is there. In non-stoichiometry, the defects which is having, which one if it is there, metal excess defect, metal deficiency defect is there. Metal excess, metal deficiency defect in the non-stoichiometry. Is mentioned in the defects in the crystal, stoichiometric, non-stoichiometric is mentioned. So in the stoichiometry, you must read that Schottky and Frenkel. It is not mentioned in the syllabus, but stoichiometric defect means Schottky and Frenkel. Non-stoichiometric is metal excess defect, metal deficiency is there, what it will be happening in the defects. Defects in the crystal also, you must read that. So the types of crystalline solids as well as X-rays based on the structure. X-ray crystallography, Bragg's equation, you must study that. And crystal lattice is what, unit cell is what, and Bravais lattice is what. And types of unit cells, face-centered, cubic unit cells and centered unit cells. Primitive unit cell, cubic and centered unit cells are BCC, FCC, body-centered, face-centered and end-face-centered unit cells which are there. And number of atoms per unit cell, how to calculate that. And after the density of the crystal and based on the unit cells, density of the unit cell is what, and packing fraction of the crystals are what, and packing coefficients or packing fraction of the different types of unit cells are what, and radius ratios and coordination and its geometries are related, how to relate it with. All those which is in the densities of the crystals, all those it is at one place. After then, based on the packing arrangement, 1D, 2D, 3D packing arrangements are how takes place. And any empty spaces are generated, that is voids, tetrahedral and octahedral voids, it may be classified in two types. And number of atoms per tetrahedral voids and octahedral voids, how to calculate that, the formula units. And further, per unit cells, how many number of tetrahedral and octahedral voids are possible, that is one case. right? Further, based on the electronic defects of the crystals, stoichiometric and non-stoichiometric is mentioned, Schottky and Frenkel, and metal excess, metal deficiency, and electronic properties of the solids. Band theory, metals, conductors, semiconductors. Semiconductors are again two types, pure semiconductor or intrinsic, another one is extrinsic. Extrinsic again two types based on the dopant atom, P type, N type. Again, temperature dependence of the semiconductor, it may be there, and temperature dependence of N type, particularly P type semiconductors are there. Photoconductivity and photovoltaic effect. Another one, magnetic properties, depending upon the magnetic properties, solids are, it may be para, dia, and ferromagnetic is there, and magnetic susceptibility is mentioned, and Lenzman theory of diamagnetism and Weiss theory of paramagnetism is mentioned in the syllabus. Weiss theory of paramagnetism. This entire unit I was uploaded in the RR Chemistry app. Entire unit with examples, previous questions, all those solid state chemistry I am uploaded in the already in the unit, except acid basis some concept and photochemistry some concept. Remaining all those I discussed in this, but in this point of view, all those units of the physical chemistry I already uploaded that. Right? In next video, I'm explaining that inorganic chemistry, how to read the inorganic chemistry syllabus and how to read the organic chemistry syllabus. Right? Thank you.